the basketball during a free throw is a projectile. A basketball relates to a projectile as the force exerted upon the basketball is a push. The basketball is then projected horizontally and vertically, causing the basketball to elevate and finally swish through the net. The horizontal and vertical components are both independent and therefore do not affect each other. The arch caused by the basketball is a result of the gravitational pull upon the basketball. Of course, in Newton's first law, if there was no gravitational pull, the basketball that is thrown would go on in the continuous path without arching forever. But due to the acceleration of gravity acting on the basketball, the arc occurs and the ball drops. When looking at energy in the ball, we start where the ball is released from the hands, and that is the 0 point. Immediately after release, it only has kinetic energy. Then as it reaches the top of its arc, it still has kinetic energy since it's moving horizontally, but all the vertical velocity energy it started with has been transferred into gravitational potential energy. And when the ball travels through the net, the ball has both kinetic and gravitational potential energy because the ball is falling and the net is higher than the release point.
When I spin the ball, I apply a torque to get it to spin. The ball then is in angular motion. The ball has an angular displacement, theta, an angular acceleration, alpha, an angular velocity, omega, which is the exact same for every spot on the ball. The angular velocity is equal to its linear velocity divided by its radius, or the change in angular displacement over time. Just like linear momentum, angular momentum is also conserved. The angular momentum of the ball depends on the ball's mass, radius, and linear velocity. So the only way I can change the momentum of the ball is if I add an outside force, or a torque, since we're talking about angular motion. The last physics concept we'll talk about is rolling motion. When the ball rolls, its energy is divided into two different types, translational kinetic and rotational kinetic energy. In translational motion, the whole ball moves together with one velocity, but in pure rotational motion, the top of the ball moves with velocity v, while the bottom of the ball moves with negative v. The middle doesn't move in rotational motion. Rolling is a mix of both types of motion, which is why the top of the rolling basketball moves with 2v. The middle moves with v, and the bottom does not move. In this way of thinking, the ball moves around a center of mass in the middle of the ball. However, there is another way of thinking about rolling motion. The point of contact with the ground could be the center, and the whole ball is just rotating around that point, which is constantly changing. But with anything involving rolling motion, there needs to be friction or it's just going to be translational energy.